So let's start with A. So just a quick reminder on L'Hopital's rule. So it shows that if the limit, if when you substitute it in you get 0 over 0 or infinity over infinity of f of x over g of x, then L'Hopital's rule shows that it's equal to the f prime of x over g prime of x. So let's put that into action. So first, let's substitute 0 into this original equation. So if we substitute 0 into this, we get that e to the minus 3 times 0 squared plus 3 cosine 2 times 0 minus 4 over 3 times 0 squared. So now and that would equal to e to the minus 3 times 0, it would be e to the 0. So this would be e to the 0 plus 3 cosine 0 minus 4 over 0. And again, this would be equal to 1, and because reminder that cosine of 0 is equal to 1. So 1 plus 3 minus 4 over 0, which is equal to 0 over 0. So first we need to show that for the mark scheme, and now we can apply L'Hopital's rule. So let's go one by one. So for e to the minus 3x squared, we're going to use the chain rule of e to the g prime is equal to g prime times e to the g. So e to the minus 3x squared prime is equal to minus 3x squared, the derivative of that would be minus 6x, e to the minus 3x squared. And now for 3 cosine 2x, you can check from the data booklet here that the derivative of cosine is negative sine, and again you apply the chain rule, so it would be minus sine, so it would be plus 3 times, so we have to, using chain rule, we have to write 2, so 2, and now minus sine of 2x, now finally minus 4, you know that the derivative of a constant is 0, so it's just 0, I'm not going to write it, over 3x squared, and as we already found, the derivative of 3x squared would be 6x, so this is over 6x. Okay, so now that's all good and all, but what you can notice is that still, if you substitute 0 over here, then obviously this term would be 0 if you substitute 0, because reminder, it's the limit is x approaches 0. Here, this here would be 0, and sine of 0 is equal to 0. So this would still be equal to 0, and 6 times 0 is 0. So this would still be 0 over 0, so now we need to apply L'Hopital's rule for a second time. So let's do that. So now we have to use the product rule, so let's quickly rewrite this. So minus 6x e to the minus 3x squared. So this would be minus 6 sine of 2x over 6x. So I'm just going to quickly do, to make my job easier, is I'm going to remove these 6's. I can cancel it out here, so this goes with this, and this goes with this. So then you can consequently write that minus x e to the minus 3x squared minus sine of 2x over x. So now we need to find the prime for the top and bottom. So for this we're going to use the product rule for this factor, this value. So u would be equal to minus x, u prime would be equal to minus 1, v is equal to e to the minus 3x squared, and v prime is equal to negative 6 e to the minus 3x squared. And then minus sine 2. So now we can write that u prime v, so u prime v plus v prime mu. So this would be equal to minus e to the minus 3x squared. And then now the minus would go with the plus, so plus 6x squared e to the minus 3x squared. And now the derivative of negative sine x, because the derivative of sine is equal to cosine, it would just be minus 2, because you have to add the 2 because that's the derivative of 2x. So minus 2 cosine of 2x. And finally, the derivative of x is just 1, so over 1. So now the limit as x approaches 0 would be equal to, this would be negative 1, sorry, this would be equal to minus 1, this would be equal to 0, and because cosine of 0 is equal to 1 again, this would be equal to minus 2 over 1, therefore this is equal to negative 3. So for A, the answer is equal to negative 3. Hence, find the limit as x approaches 0 of this following expression. So, I'm just going to take a picture so we can solve that here. So, okay, so now to solve this expression, there's a few things we can do. One is because x approaches to 0, you can see that if you substitute 0 into this equation, the integrals are going to be as follows. The integrals will be from 0 to 0. So that means the area defined under the graph will be equal to 0. So therefore, these are equal to 0. So these two integrals are equal to 0, 1 and 2. So now we get 0 over 0, and thus we can write L'Hopital's rule. So this would be equal to 0 over 0, L'Hopital's rule. However, since these are the antiderivatives of our original function, we know that the derivative of an antiderivative, so f prime of x, where the big F is the antiderivative, is just equal to f of x. So that means we're back to our original expression of e to the minus 3t squared plus 3 cosine 2t minus 4 over 3t squared, which is, and if you notice, this is equal to the same thing as here. So these two will have the same answer of minus 3.